Thank you so much to the Vercel team. It's an honor to be sharing some of the things I want to talk to you about today. How many of you, show of hands, have seen this framework for building software? Make it work, make it right, make it fast. Who's heard of this? Yeah, I've used this framework for years. It's how I thought about building good software. It was popularized by Kent Beck and some of his writings about test-driven development. And how many of you who have used it, it ends up working something like this? You spend all of the time on make it work, a little bit of extra time on make it right, figure out those edge cases and stuff, and then a little bit, tiny bit of time at the end for make it fast, whatever's left over right before your deadline. Does that sound familiar to anyone? Yeah. When building a really high-performant, very dynamic web app in Frame.io, we found out that this framework just didn't work for us, despite it working for me for years. And I'm sure there's plenty, I know, there are plenty of applications where this works well. We found that for us, making really fluid interfaces on the web, this was not the way. Who am I? My name is Charlton Roberts. Like Sarah mentioned, I work at Frame.io. We were acquired by Adobe 2 years ago. I've worked at some of these other companies as well, building high-performance websites and web apps for about 15 years. And for the last 3 years, I've been working on the next version of Frame.io. We call it version 4. Sort of in stealth mode. The version, if you've used Frame.io before, it's a video collaboration and asset management tool. The one in production is not on Next, but this one we launched in April is. It's on Next.js and in Vercel. And this is a real live screenshot. It's just this snappy with all these panels and lots of stuff going on. There's a lot to think about. And with version 4, in addition to a bunch of the features that we had planned for this next generation, everything that our customers were asking for us around metadata and asset management, one of the really aspirational principles for us was we wanted desktop-level performance, desktop app-level performance on the web. Really tough problem. It took us years to figure out how to do this, and we're still not perfect at it. But this was the vision for version 4, and we wanted to figure out how to do that. If you're not familiar with Frame.io, you've probably seen something that's been collaborated on in Frame.io. Vercel themselves are actually customers. A lot of the ship materials I heard were approved in Frame.io. Everything from Hollywood movies to television shows you've heard of. But also, every company is kind of a video company now. So we have customers like Golden State Warriors. They chop up live broadcasts to their socials, as well as big brands like Ford making advertisements and things like that. And they're making really high-quality content, and they see in milliseconds already. They see in frames, actually, Frame.io. But they're making this really high-quality content at really high frame rates and things like that. And we realized that our customers already see in these milliseconds, they already see in frames, and we're going to have to meet them where they are. If we want to deliver a compelling experience for them, we're going to have to deliver something as performant as a movie, basically, right? And that's where we got this desktop-level performance, because they're editing a lot of these videos in desktop apps, and then they go to Frame.io for their review and approval. So we want to match that experience. These are two numbers that I think every web developer should know by heart. 60 frames per second and 16 milliseconds. We spend so much time thinking about these two numbers and agonizing over them. 60 frames per second, if you don't know, is the frame rate of the web. There are monitors and phones that go above that. Sometimes you can get away with going below that. But at Frame.io, we just pick 60 frames per second. It's going to be our benchmark. And at 60 frames per second, the duration of one frame is 16 milliseconds. And we spend a lot of time figuring out what's supposed to happen in a given 16 millisecond chunk of time. And so we started version 4 with that old framework, make it work, make it right, make it fast. And it went something like this. Probably sounds familiar. We make the first version, it's janky, but it works, it proves the point. And then you get to make it right, which is, oh, we got to do the error cases and the edge cases. And it's still a little janky, but maybe a little better, but it's actually slower now because it has to account for all that other stuff. And then right at the end, right before we ship this feature, we try to find the low-hanging fruit to make it fast just for that right feature. And what we found over and over again was that this process resulted in something that just didn't feel good. It didn't feel good. And we had to deliver something that felt good. If a single dropped frame in an Oscar award-winning movie, that's like what we would consider an incident, right? Like they're not going to ship the movie to theaters if it's dropping a frame. That's the expectation that our customers have from us, and that's the expectation we set for ourselves. This process wasn't getting us there. Wasn't cohesive, delays everywhere, jank, everything. And the worst part was, everyone was doing their job. All the teams were doing exactly what we asked of them, and the result didn't get us there. So it wasn't the failings of anyone, building the things. It was the failings of our approach, how we were actually getting there. And so we thought, if the result isn't getting us what we want, if it's not feeling good at the end, what if we start with that? What if how it feels is as important as how it works the entire way through the process? And we started to reimagine a development flow and a bunch of principles and how we think about shipping software around this idea that how it feels is important as how it works. For us, performance is a feature. If it doesn't feel good, it's not working. And that sort of set the tone for everything we wanted to ship in V4. But that's a principle, right? You can think about how it feels equals how it works. But how do you turn that into something a team can do and action on? In 2018, Apple at a WWDC conference, they gave a talk called Designing Fluid Interfaces. If you've never seen it, highly encourage you to watch it. From that, our founder, Emery Wells, saw this vision for that type of designing a fluid interface and came up with all of these principles for how we wanted to ship stuff on the web. And in that talk, they talk about how when software is really working and when you're in the flow state and the software is just clipping along with you, it feels like an extension of your mind. It feels like you're superhuman, right? I think hopefully you've been there, where you just feel like it's moving as fast as you can think. And we want to keep up that illusion the entire time the user's using our application. And I love this metaphor of never drop the illusion because it implies that on one side you have this very smooth, simple, easy-to-use experience, but it implies this huge amount of work, like a magician, that goes into making that happen. It doesn't take for granted all the things that you have to do to actually get there and keep this magic happening. So if you know sort of where you're going, how do you get a team to understand if the illusion's working or not? You need some cold, hard numbers to talk about, and you need a set of principles that you can point to and say, this doesn't meet these principles. For us, we've called this Fluid UI. There's some other Fluid UIs out there. I think there's a design system and stuff, but we spent a lot of time talking about Fluid UI and the principles of Fluid UI in building high-performance web apps. There's a lot of principles, but there's 3 of them that we probably spend 80% of our time on, and I would argue if you get these 3 right, you're going to have an application that feels good. There's some other stuff you can make it feel even better, but these 3 are just critical: instant, smooth, and coordinated. Instant is the idea that your application has to respond to the user instantaneously. It has to feel like the same moment. And I'll spare you all the scientific details, but for us humans, that's usually 100 milliseconds. You have 100 milliseconds to respond to the user and let them know that you know what they're trying to do. And at 60 frames per second, that's 6 frames. That's your threshold. That's your limit. There is INP is a interaction in next performance, interaction in next paint. Sorry, is a performance metric, and that roughly correlates to what we're talking about here. But for us, we just get a lot of value with stepping through frames and counting. Was it over or under 6 frames? Because that's our threshold. And importantly, it doesn't have to respond with the end state, what your application's eventually going to show them, although that's ideal, right? We want optimistic states and all that sort of stuff. But you just have to respond with something that lets them know that you're on the way to doing it. It could be an intermediate state or a loading state or something like that. Second is smooth. This one's a little bit more self-evident. It's the fact that animations have to run at 60 frames per second. Can't have any dropped frames or any skipped frames. And then the last one's a little bit hard to grok and talk about, but I would argue it's the most impactful. Coordinated is the idea that everything happens in one sort of same fluid motion. The metaphor I use a lot with the team is when the users does a click event or a keyboard event, something like that, they are putting energy into the system, into our UI, and the UI needs to respond with one motion. That doesn't mean it happens at the same time. It could be in staggered and coordinated, orchestrated, we often call it. But it needs to feel like the same thing. And I'm going to show you some examples of that. So let's dive into some cold, hard examples, actually. The first is instant. So this is the frame.io interface. We want to show how we're responding within 100 milliseconds for this interaction. We're looking at a folder of some assets, and we're just going to click. We're active in the bcam folder. We're going to activate the acam folder. So this is real time. Let's watch it. Very simple. Now we're going to do exactly what we do at frame.io, which is we zoom in. We upload the screenshot to frame.io. This is the actual frame.io player you're looking at here. And now we're going to step through frame by frame, and we're going to talk about what's happening. I want you to look at two things for this interaction. One is how quickly we update the acam. That's because that's happening on the mouse down event. We're actually doing that before the click event happens. And that's local UI. We want to update that like within a couple of frames if we can. And then everything else, breadcrumbs, the thumbnails in the bottom right, everything else is going to happen also within about 5 or 6 frames. So you can see it step, step, step. You can see the mouse getting smaller. Acam is active. And everything else happens in a few. That's how we debug if something's instant, right there. Let's watch it again in real time. So if something's not instant, there are some tactics. There's many tactics we've come up with. A lot of them are nuanced, but these are I try to condense it down to the ones are most important to share. One of them is making sure don't be scared of local state and use state and use optimistic local to your component for updating instantaneously if you can. If you're going for performance, you're going to want to do this. You're going to update that local UI before you tell the rest of your application what happened. The second one is we've been very pleased with the app router and router cache. As the user is clicking around, we often find that we get single frame navigations if a customer is going back to a cached route. And then the last one, I wish there were a magic bullet here, because it's where we spend most of our time. We're excited about React Compiler for helping us solve some of these things. But oftentimes, you're not hitting 6 frames because your browser is just recomputing something that it doesn't need to recompute. And so you need to add a use memo, use callback, something to make sure the browser is free to respond to you and not some other update. Next up is smooth. This one's a little easier to describe with an animation. So just to level set, I know everyone knows what we're talking about with frames per second, but what I want you to look at in this animation is that for a given space and time that are fixed, the box moving the same space and time, it's how many times we see the box in the intermediate states. That's what we're going to look at. And notice that they're equally distant. I mean, that's a linear curve, but in your mind, when we're thinking about this, just an equal distance between them in time is kind of what we're thinking about. And so now we're going to take this box. This animation was designed by my friend Sina, sitting right over here. And we're going to step through the box moving from the bottom left to the top right, frame by frame. And so we're starting off frame 1, frame 2, frame 3, frame 4. Oh, now we're asking the browser to do something really expensive. And it's got to go figure out, fetch some data, something like that. Well, time moves on. So now we're in frame 5, but the box is still in position 4. Now we get to frame 6. The browser's freed up. It can catch up. OK, let's jump to frame 6. We've dropped frame 5 here, right? That is a frame drop. That's what we're talking about. We look for these everywhere. It's what you feel in Jank. And here's what it feels like. Pop. You see that pop right there? It's very hard to see in real time, but if you slow it down, this is what can make your application feel not smooth. So without all the stuff around it, pop. And then one more time at real speed. Hopefully that's coming across up there. Some things you can do if you're finding a dropped frame. We use a lot of use transition, love concurrent rendering. Use transition is just a way to tell React, I have something really important and something really expensive, and I want you to do the important thing first and the expensive thing later. If there's one takeaway I could give you from migrating a 400,000 line code base from the pages router to the app router, it would be prefer CSS solutions everywhere if you can. That will be your saving grace. There's a lot of benefits. There's bundle size benefits and everything. But it really, you just can't beat the fact that if you're moving animations out of JavaScript and into CSS, it's going to be smoother. And then just as important for animating the things that do move on the page, you want to make sure you're not unmounting and remounting things that shouldn't be changing. Next gives you a lot of tools for this, parallel routes, layouts, that type of thing. But this one can be really tough to spot because often it's like so fast you don't even see it. But if you slow it down in these slower screen recordings, you can actually see like a flicker, and it'll let you know that something's unmounting and remounting. The last one is coordinated. We're going to do the same thing here. We're going to look at interaction. And we're going to open what we call the project switcher and change projects. And there's a bug in here, and I want to see if you can catch it. Did you catch it? I didn't until I made this slide deck. So, all right, there's 3 things I want you to look at. This is coordinated is a little bit more difficult to communicate, but there's 3 things I want you to look at, and then I'll tell you the bug. The first thing is we're going to show that active state of casting auditions very quickly. We're going to blur the search projects on mouse down. I think we actually activate casting and auditions on mouse up, but we should probably move that to mouse down. And then the second thing is the largest contentful paint of this interaction, where the sheet animates out, the thumbnails in the bottom right are going to unmount, and the project name at the top is going to change. Those all happen at the same frame. That's very important. That's what we mean by coordinated. If they happened at different times, it would feel janky. Oftentimes, your saving grace here is moving things like using routing as your source of truth. That's what we're doing here. But that's what we mean by coordinated. And then crucially, the third thing is the content that comes as a result of the navigation, all assets, you're going to see a folder tree, all assets, and the thumbnails coming back up. Those come later, but still together. If those happened out of sync, it would still feel janky. So let's watch those 3 things. Oh, and the bug is when we change to casting out auditions, the name at the top, there's going to be like 3 frames where the avatar isn't visible. We're going to show like an empty box. It's going to be purple because there's a purple thing behind it, and then it'll change to that avatar that we already have. So there's a bug here that I certainly didn't see it until you step through it, and this is the type of thing you can catch when you're looking for coordinated actions. Let's step through, step, step. All right, so search projects gets blurred, casting out auditions responds within that 6 frames. Watch this 1 frame. Everything happens at the same time. And then all assets and the thumbnails are going to come in within a couple of frames. If you have a little more wiggle room, it doesn't have to be exactly the same. So now let's zoom out and watch it at full speed again. Great. So now we have this shared vision of where we're going. Instant, smooth, coordinated. The team knows what the goal is. They're building these features in isolation. They get it up for review to leadership, and what happens? It still doesn't feel good. I don't know about you, but when you poured your heart and soul into something and it's still rejected and you know it doesn't really feel good, it feels awful, and you don't know what you're doing, or don't know how to account for that. What was happening was we were building for Fluid UI in these for feature-specific places, but we still hadn't cracked how to make it cohesive with the rest of the app. Features were interfering with one another, and like we'd get this death by 1,000 cuts where this team would ship something, this team would ship something, and then you look back and all of a sudden everything's janky again. But we did find that we were really good at mobilizing on fixing stuff that when we found a single interaction we wanted to fix. We could figure out that. So we thought, what if we take what happens in that fixing stage and move it earlier? And for that, we need a shared expectation of how we're going to get there with the rest of the team. We came up with a lot of principles for this, but these are the 2 I think that are most important, the one we spend most of our time on: instant and infinity, and optimize for the right work. Instant is a little bit different instant. It assumes you're hitting that 6-frame threshold, but it's more of a question. How are you going to keep it instant? How are you going to make sure that your local change is going to be prioritized over other expensive stuff happening? With infinity, it's the idea that everything on the page that's a list, a customer someday is going to try to make it infinite. They're going to try to make it millions of stuff. And you don't have to build it so it accounts for that, but you need a plan. What's going to happen when the customer does that? That's a continuum. We do everything from setting a limit, so you just can't do it. It's an impossible state, all the way to that thumbnail grid you saw. We call it the finder. And we have some of our most talented engineers, some of them are here today, that spend all day tuning that finder to make it Fluid UI compatible and also handle millions of assets. So you can choose to just dedicate a ton of resources to that really hard problem. The other one is optimize for the right work. This is all about, often when you have Fluid UI issues, it's because 2 things are trying to happen at the same time. JavaScript is single-threaded, that can't happen. So there's 3 ways to account for that. You can defer, make one happen later. Can it wait for things? You can use things like request idle callback. An example here is like we were loading data for a right-click context menu that you didn't need on load. You could load that later, right? Defer it. Another one is anticipate. Can one of those things move earlier? Again, Next helps us out here with prefetch. There's a prefetch true setting if you have a very dynamic app with not tons of static pages. That'll actually go hit the server request, the server component, and get you all the data so that by the time you actually click the thing, it's instant. And then offload. Does it belong there at all? 2 examples here. All of our uploads, we move to a web worker. Just get it off the main thread. Don't let it compete for resources. And then a ton of times, I'm certainly guilty of this a lot, we find developers would put stuff on the main thread that just shouldn't be on the client at all. It needs to be an API somewhere. It needs to be a service. We need to offload that from the main thread. So we have these shared expectations, but how are we going to avoid that death by 1,000 cuts issue? The biggest sort of thing that's helped us was making fluid UI regressions in production a PR blocker. You cannot merge your PR if you're introducing something that makes something less instant, less smooth, less coordinated. It's a hard pill to swallow at first, but then everyone's on board and everyone's sort of swimming or rowing in the same direction. This is obviously for production stuff, which means for non-production things where you're iterating, you have to use a feature flag, and the feature flag can only come off when that feature, when turned off or turned on, is fully fluid UI with the rest of the application. And then also we just periodically go audit the app just to see what's happening. Has anything changed in the last few weeks that we haven't accounted for? And then, I don't know about you, but I certainly, when I started this job, I couldn't see in milliseconds all those things I showed you earlier. I definitely couldn't see. I can barely see them now if I look really hard. So how do you teach your team to see in those milliseconds, to see in those frames? And there's a couple of tactics here. So one is we now account for fluid UI as being about half the time we spend on stuff. And that goes back to how it feels equals how it works, right? If those 2 things are equal, they need equal time, equal weight, equal attention, equal resources, and we just plan from that from the beginning. It doesn't surprise us anymore when Fluid UI takes half the time to build something. The other thing is using the right tools. I showed you how to step through screen recordings, invaluable technique, highly recommend it. And then we also use things like Storybook to peel away the rest of the app. Obviously, something can't be fast in the app if it's not fast in isolation. And then when you hit those road bumps, know who's going to jump in and fix them, right? Not everyone's equipped to do that. For larger teams, you can do something like what we have at Frame.io. We have a team called Interface Architecture. They're all here today. They're very talented engineers. And we focus on the app-wide performance. And we're not building performance for all the features, but we're the ones accountable for it. If performance is a feature, you need someone that delivers it as a feature, that monitors it and tracks it and works with teams to help them deliver it for their features. The second one is conquering the hardest challenges. So when a team is up against a deadline and something's not Fluid UI compliant, there's a temptation to cut a corner, right? To hit that deadline because maybe someone's not looking, not out of any ill will or malice. They're just that seems like the right path. And now we have this team to go embed with them and help them hit the deadline, but also help them meet these principles. And then last, it's a team that looks for step function improvements across the whole app. What are the things that are going to make everything faster and not take any extra effort by the rest of your team? These things are super important too. For us, this was the app router. It took us months, but we really wanted those one-frame cache navigations. And the work wasn't just migrating it, although that was some work, but it was also migrating in a way that didn't slow down the other teams, that educated them about this new architecture and how to use it, how to leverage it, that type of thing. So I'll be the first to admit we are not perfect at all. It is an ever, we will never get there. I don't know the right phrase, but it is something we will continually work for, getting to this perfect Fluid UI app. But we are very proud of some of these principles we've developed and discovered along the way about how to build this. We now have this shared vision. The end goal is clear. We want it instant, smooth, and coordinated. We call that Fluid UI. We have the shared expectations of how to get there. You can't merge your PR if it introduces a regression, and it's going to take you about half the time to get there. And we have these dedicated resources. We know what happens when we hit a road bump and someone can't meet those requirements. These principles have worked really well for us. It helps us really get close to never dropping the illusion. and our idea of desktop performance on the web. I hope you found this helpful, and thanks so much. Appreciate it.